today. Today we would have a lot of we would have instructors and teaching assistants that would be joining us to take different sections. We have different section, and for this morning section, we would have both the instruction and the hands-on section that is going to last for about 50 minutes. And we're going to be starting this first section with basic statistics. And of course, our instructor is already sharing his screen. His name, Deepan, you would forgive me if I pronounce your name wrongly. I don't know how to pronounce the other part. But our instructor this morning is Deepan. Deepan, help me complete your surname.
Oh, okay. It's
Thank you
Pitchairaj.
so much. Pitchairaj. So he would be joining us from India this morning. He'll be taking this morning section. Please
from India. Wow.
Yeah, yes. We have instructors from different parts of the world that'll be taking us on different sections. So he's going to be taking us right away. Please, if you have any question, please drop it in the comment section. And also don't forget the attendance. I'm going to be dropping the link in the chat box. In case you did not receive it in your email, I'll be dropping it shortly. But please put your questions down. There'll be a time for question and answer, and then you can ask your questions. But you can also drop it on the chat box in case so you don't forget. So Deepan, you can go ahead, please. Thank you.
Okay. So hey everyone. So am I audible to everyone?
Yes, I can hear you. I don't know.
Yes.
Hello.
Okay. So I welcome you all to this Data Science and Artificial Intelligence Symposium 2024. Let me introduce myself once again. My name is Deepan Pitchairaj, and I'm doing Masters in Biostatistics at National Institute of Mental Health and Neurosciences, Bangalore, India. And this course is about basic statistics. To be honest, it is really basic statistics. And I'm not going to touch any theoretical aspects of the concepts that we're going to see here. But anyway, it will give you an overall idea about statistics. And also, I encourage you to explore the things on your own. So we're going to go very slowly. And then let's see. Okay, this is the outline of the contents that we're going to see here. But before that, I would like to set up a stage for everyone to understand statistics, because not everyone will have some idea about what is this data science and statistics is all about. Okay, so we're going to have an introduction. But before that, I would like to ask you one question. Okay, so can you please tell me what is the probability of getting a head if I toss a single fair coin? Can you able to? So imagine you are having a fair coin. 1/2 or 50%, right? So can you type all your responses in the chat box? Like, I want to know like whether everyone is on the same boat or not. Okay, it's actually 50%, right? 50-50. So I'm glad to see that you are having some background in probability. Okay, that will be helpful when we are seeing the p-values. Okay, so we're going to answer these questions: what, where, why, when, and how, to understand data. Okay, it's actually crucial for statistics, because statistics is all about dealing with data. Okay, so what is data? So data is a collection of facts and information and statistics, and this can be in various forms, such as it can be a number, it can be text or sound, images, or any other format that can be understandable by the human mind. Okay, well, the thing is about you should be able to measure it, or you should be able to find some patterns in it. Then only you can call that as a data. Okay, so I would like to emphasize some of the words that is given in this definition. You can find something like collection of facts, information, and statistics, right? So this statistics is not about a single entity. Okay, it's about always a collection of entity. So I don't know, you are aware of Joseph Stalin's quote. What he says is a single death is a tragedy, and a million deaths is a statistic. Okay, so what he means by that is collection of data. Can you able to see my screen?
Yes, we can.
Yes.
Yeah.
Okay. So it's about the collection of data, not a single entity. So you have to think, you have to keep this in your mind. Always think as a whole, not about the single entity. Okay. And also, if you notice, I placed facts and informations are more or less having the same meaning, but I placed statistics along with facts and information. This may be quite confusing for a beginner. It's because previously I said data statistics is all about dealing with data, but now I'm defining data in terms of statistics. So this will be um, addressed in the upcoming slides, and we can move on to where we can get the data. So the answer is you can get data from anywhere as you like. It depends on your research question or your interest. But if you ask me precisely, can you name some industries where data-driven approach is going on nowadays? Is medicine and health care, agriculture, manufacturing, finance and banking, and human resources. There are so many sectors you can name it. Okay, and these are the people who are using data largely. But actually, in science, whatever things that you want to prove, you have to prove it statistically. Even it can be a particle physics, something like this quantum physics and all. They also need to use statistics to prove their results. Okay, so everyone needs statistics to prove their results. Okay, now we can go to the question why we want to collect the data and doing this analysis and all. Okay, imagine you are having some disease and going to a doctor. Okay, so what are the questions that he will ask? He will ask, what's your problem? Like, how long you are having this problem? And then, what are the symptoms that you are experiencing? And then he will ask your weight, height, and where is your house? And then your age. So all these things are kind of information. But if you see these things as in a perspective of a statistician or analyst, what the doctor is actually doing is actually collecting the data from the patient. Okay, so based on the data, he's processing in his mind, and then he will treat the patients with the appropriate treatment. Okay, and that's why we want data to plan our further actions. Okay, so now you understood, like this data will be very much helpful on decisions, as well as it will be helpful on understanding what is actually going right now. Okay, for instance, you can take this as an example, but in the case of doctor, you can find only two persons. One is the doctor and the patient. Then the process is very simple. The doctor will have the questions and he will ask the patient, and the patient will give the answers. No, so the data collection process, analysis, everything will be done within a minutes. Okay, but in reality, as a data scientist or a statistician, it won't be that much easy. The data collection process will have a lot of time, the analysis, everything will have a lot of time. So you can take this as an instance of this discovery of cholera by John Snow. Around 1800s there was an outbreak of cholera, and people before that thought about cholera is like it's spreading because of air. Okay, there is no theory like it's spreading by water. Okay, and also in that time it is around 20 years before the invention of microscope. So people don't have any theory of microorganisms, and they don't know anything about this microscopic world. Okay, in that time itself, this John Snow, he's a doctor and he's considered to be the father of modern, epidemiology. Okay, so he, based on the statistical evidence, like he collected the data of where these deaths were located and what is the reason for the death, everything. Based on that, he have a statistical evidence which help him to prove the hypothesis that this cholera is spread by water. Okay, is that clear? So this is one of the reason that we need data to prove our hypothesis or our thought. Okay, and secondly, you can see governments and business. You know, for policy making, the government will be depend on the citizens' data to forming new policies. And for business, they will be very much interested on the customers' data to bring up new products, and they will get to know about how a product is performing. And lastly, it can be you. Okay. For example, you may be interested in joining a new university. So at the time, what you will do, you will get a list of universities and you will get to know about what are the courses and what is the curriculum, who's the faculty, what is the experience of the faculty, and then what is their specialization, what is the number of students, what is the acceptance rate, and what's the fee structure. You can ask so many questions, depends on your interest, right? And these are all informations. Okay, with that you will be able to make decisions, or you will get to know about what is the circumstance. Okay, so and then we can move on to when we can collect the data. Okay, so imagine your event of interest happen in the previous week or in the previous year. You need to collect the data that belongs to the particular time frame, not in the current data, or maybe after 10 days. Okay, you need to know what is the right time this incident may happen, and then you have to collect the data in that particular time. So that is the answer for when we can collect the data. And for the question of how we could collect the data, is need some little more elaboration. Like, depends on the source of data. You can classify data in like primary data and secondary data. Okay, so primary data means that the person who is collecting the data and the analyst, or more or less, they are involved in the process. So the analyst will have the control of what are the data that will be collected during the survey. Okay, but in the case of secondary data, the analyst will do the analysis job, but he will not be involved in the process of data collection. What he will do, he will get the data from somewhere that is collected by someone, and then he will start doing the analysis. So in that case, this data will be classified as primary data and secondary data. I'm going to skip these things like this survey data, experimental, and observation, but maybe we can see this one, this public data. So public data, by the name itself, you can understand these data will be available publicly, and you can find it in newspaper, magazines, or in some websites, or it will be published by the government in some government websites, or you can find it some websites like Internet Movie Database, like IMDb, where you can get a lot of information about the movies, right? So these are called public data. So in the case of public data, how can you get this data and then start processing the information? So you can use a technique called web scraping. Hello. So we can use a technique called web scraping. Can you please mute? Okay, so you can use a technique called web scraping, and these are the tools that will be very much helpful in web scraping. What it means is you will use these tools to scrap the data that is available on the website. Okay, so some of the tools are called Scrappy, Beautiful Soup, Selenium, Request, or some of the packages in Python where you can use it for collecting the data. Okay, and the next one is called the private data. So this data will be collected by some organizations for their purpose, or maybe for some general purpose. So if you want to do the analysis in that particular area, and you are hoping that this company will have that particular data, you have to give them money, and then you have to get the data, and then you can do the analysis. And the last one is the personal data. So this is the data that is collected from a user, like who is using the cell phones. Say for example, Instagram or YouTube, they will collect your personal data, like you are scrolling, and then they will get to know what is your interest, and based on that they are doing the digital marketing, right? For example, they will promote a specific product that will be very much matching to your interest. You will be searching that in Google, and later in Instagram you can find the same product. So it is a kind of personalized advertisement, no? So it depends on this personal data. So these are the classifications of the data. More you can read about these things and the following websites. Okay, shall we move on to the next one? So the steps involved in data analysis is, you may heard of my words, like I used to tell again and again about the research question, research question, research question, no? So the job of the analyst is more or less like a detective, or investigator. You can think yourself as like Sherlock Holmes, and he will find some evidence about some crime scenes, right? So likewise, if you want to prove something in science, you need to have some proper evidence, but before that you need to understand what is the exact problem. So you need to clearly define the problem, and then you need to know what is the expected outcome, and you should have a proper team, and you cannot do everything by yourself. You need to just split out all the works to some people and then do the job. Okay, and then you need to have a clear execution plan, and you need to know where the plan will succeed and where the plan will fall. Okay, and then you need to prepare the data. Okay, after defining the problem clearly, and then you have to prepare the data, you have to collect the data, and then you have to categorize them, and then you have to clean it. Cleaning is the major work of many data analysts, because the data won't be very much perfect when you start doing analysis. It will have a lot of anomalies, and then you need to find a lot of methods to handle it. So where we will use data imputation, even that itself will have a lot of theories, like whether we can remove a particular record or can we place it, what kind of replacement will be done, is all comes under the data cleaning part. And what about the transformation? Can you please mute? So the data transformation is about, so we're going to use statistics, right? So statistics will have a lot of techniques and the methods, and all these methods are based on some statistical assumptions. It is done by the person who created the method. Okay, so first of all, to apply those methods, your data need to be following or satisfying all those assumptions. If it is not following those assumptions, you need to transform the data accordingly to make it to follow the assumptions. Okay, and then you can partition the data, and then you need to find, when it comes to implementation of the analysis, you need to find proper statistical methods to carry out your analysis. And then later, after the analysis, you will find some useful insights, right? You need to know how can we integrate this particular data driven solution to your business, and then get the useful results from the business. Okay, so when we talk about this implementation of the analysis, you can find four types of analytics. One is called the descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. So this descriptive analytics is all about just showing a picture of what happened in the past. Okay, what is the current scenario? How is it going? So everything will be shown in the analysis of descriptive analytics. Okay, and when it comes to diagnostic analytics, it's about, you may found something happened in the past, but you need to tell why that thing happened. So that you have to tell what is the cause for that event. Okay, so that comes under the diagnostic analytics. And the third one is called the predictive analytics. So based on the past data, can I guess what is going to happen in the future? So this will be handled by some linear models or generalized linear models, and everything comes under this predictive analytics. Okay, the last one is called the prescriptive analytics. Is that, can you give some suggestions based on the data that you are having? Is based on the prescriptive analytics. Okay. So now we can get into what is statistics. I hope you are clear with the things that is about data analysis and all, right? Okay. So when it comes to definition of statistics, statistics have two meanings. One is a singular meaning and another one is a plural meaning. Let me start with the plural meaning first, and then we can get into the singular meaning next. Okay, so when you can find in newspapers or in some advertisements, say for example, for a toothpaste advertisement, you can see they will use a word like 4 out of 5 dentists is recommending this particular toothpaste, right? And then the average of this particular player and the median salary, all these words will be used in newspapers, magazines, or advertisements are statistical terms. Okay, and this 4 out of 5 is more or less like an information. Okay, so that is what I emphasized in the first slide, where I placed statistics along with the information. Okay, so in that way, statistics will become information. Okay, then what about the singular meaning? It's statistics is a scientific method of collecting, organizing, summarizing, presenting, analyzing, and interpretation of the data. Okay, it's just a method. It is like all methods dealing with all this process. Okay, and then we can see each and everything one by one, the collection of data. Okay, so when it comes to collecting a data, you will have two sets. One is a population and another one is a sample. Okay, so what is a population? Population is the entire space where the that will be your interest. Okay, say for example, I want to know the IQ or what is the education performance of students in Nigeria. My entire population will be Nigeria people, right? So I cannot take a Russian or some Indian people and then do the analysis, right? So this is like entire space. That is what we call it as a population. Okay, so what is a sample? Sample, by the name you can understand, it's like a subset of the uh, population. Okay, I can give you another one example. Like you should not always expect the population and sample are always about the people. Okay, imagine you are having some disease and say for example, the doctor wants to know based on some test. Okay, he will not take all of your blood, right? He will just take a sample of your blood, and based on that, he will find whether any germs present in that blood, and then they will give the diagnosis based on that. Okay, so in that case, your entire body is the population, and the sample of that blood is the sample. Okay, I can give more examples. Like if you are in a manufacturing sector, all the products produced is the population, and you need to get a small sample out of them. You need to find how the process is going, whether is there any defective items are there, and this is how the difference between population and sample. Okay, so if you are collecting the data from the entire population, is called the complete enumeration method. Okay, and if you are collecting the data from a sample of the population, it's called sampling. This sampling is a very big topic in statistics, and it will have a lot of theory, and that is called a sampling theory. Okay, we are not going to touch that, but you can see some the statistics even more classified as descriptive statistics and inferential statistics. Okay, so descriptive statistics is like more or less like a descriptive analytics. You're going to just to show what is really happening based on the numbers. You will just give some numerical figures or some diagrams about what is having in your hand, and then you will just show something that is happening right now based on the data that you are having in your hand. What is this inferential statistics is that you will collect the data from a sample and then you will give a conclusion to the entire population. And that's what this inferential statistics is all about. Okay, you will give a meaningful conclusion on the sample data drawn from a large population. Okay. Hello. So even you can classify the data um, even more. Like you can classify the data based on its nature. You can classify them as qualitative data and quantitative data. This quantitative data is even more classified as discrete data and continuous data. So what this qualitative data is about, it represents some of the characteristics or attributes. Say for example, you are collecting some data from some patients. Okay, and what they are telling is I'm a smoker and I'm a not smoker. So this kind of data is like a qualitative data. You are asking some questions like whether you are a male or a female, what is your religion, and whether what is your socioeconomic status. Are you from some high class or a middle class or a low class? These all things comes under the qualitative data. And what is this quantitative data is about showing the exact numerical figures. Like what is your height? You will give some numbers, right? And what is your weight? Like how long you are not sleeping properly, and then how many days you are having these symptoms, and how many times you vomited, or these all things will comes under the quantitative data. But this discrete terms will represent a whole numbers, like it represents a count, how many times some event has happened, like that. And the continuous part will represent the numerical figures that can be even more estimated precisely with the more advanced tools. Say for example, if I'm telling my height is around 170 centimeter, if you bring me another one more precise tool, that tool will give me my height as 170.12 centimeter, right? So when the precision of the instrument is getting increased, your data will also will be more precise, right? So that these kind of data will be called as continuous data. And based on the measurement, the data is classified. There are four scales in uh, the data classification. One is called the nominal data, ordinal data, interval data, and ratio data. I mean ratio scale. Okay, so in the case of nominal, I said about male and female, smoker, non-smoker, isn't it? So you cannot find any order in them, and it just represents some categories, right? So these things will be called as nominal scale. And if you find some order in the data, like the categories, among the categories, say for example, you are telling about a disease, like the disease will have some three stages: stage 1, stage 2, and stage 3. Even those things represent some of the categories. Among them, you can find some order, which comes first, which comes next, and what is the third one. And in some cases, you can find something like a rating from a user, right? The rating will be from 1 to 5. Even it is a category, you can find some order like 1, 2, 3, and 4. And what about the ratio scale? Ratio scales are more or less like exact numbers. And then where you can just only add and subtract numbers. One of the example is a temperature in Celsius and Fahrenheit. And when it comes to ratio scale, uh, the example will be like it will have a true zero. True zero in the sense it represents the quantity is nothing there, but that is the only difference between the interval scale and the ratio scale. The interval scale will not have a true zero. What it means that if I say 0 degree in Celsius, it will refers to minus 32 degree Fahrenheit in Fahrenheit scale. So that is an example. It won't have a true zero. You cannot tell, okay, this zero is there in Celsius and it will have a representation in another scale. Okay, and that is an example of interval scale. And when it comes to ratio scale, if I say zero age or zero weight, it represents zero, right? It is nothing. Nothing is there. You cannot say in grams it is 0 kg. I mean 0 grams. And in kilograms also, it will have 0 kilograms. It means that there is nothing there. So that is a representation of true zero. And when it comes to organizing this data, we will use based on their classification. You can organize this data in terms of a frequency table. And first of all, we're going to see qualitative data. Say, for example, you are asking the students in a class like, what is the party that you are interested to vote? You will get some answers like Democratic, Republican, or any other parties. Okay. So based on that, you can prepare a frequency table like these many people belongs to this particular category, these people are voting for Republican and others. So this way you can organize the data for qualitative data. Okay, so there is no numerical figures there. It represents some of the categories what people interested to votes. Okay, and then when it comes to quantitative data, I said it can be classified as discrete and continuous. So if I ask you how many members present in your family, you can give me some answers like 1, 2, 3, 4, 5, 6. You cannot give me answer like I have 1.5 persons in my family, right? So in that case, those will be comes under the discrete data. And then here again, you can create a frequency table based on that. And when it comes to continuous data, if I ask you something like, what is your weight? You can give me some numbers like I'm 55 kg, 50.8 kg, 52.1 kg. But I already said that based on the precision, this value will change. Okay, when the instrument is getting more and more precise, the data will be more and more precise. So in that case, to avoid that situation, you can use intervals to capture this information. So you can build these intervals. I will show you some methods in the Google Colab session. And based on that, you can prepare these intervals. And then if the person belongs to 55, you can find this interval and then put 1 there. And likewise, you can see how the frequency, how the counts is distributed among these values. This is a very much important thing that you need to focus in statistics, because statistics is like a tails of distribution. Mostly people will deals with this distribution, whatever they are doing with probability. This is the hardest part in learning statistics. You have to know how this counts or the frequencies are distributed on the values, like whether it is a numbers, or whether they are the intervals, or whether it can be categories. You need to know how these frequencies or the counts is distributed. Just please note the word distributed, or distribution is distributed along these values. Okay. And this is about organizing the data. So we have seen collecting the data and organizing the data, right? And here comes the thing called data frames, and this will be very much useful when you going to deal with data in something like a Google Colab or Jupyter Notebook or any other thing that that you're going to use for data analysis. Okay, so the data frames are more or less like a table, and you see these are called columns. Like this, names, teams, number, position are called columns, and you can find the rows. Like this particular thing is a row. Okay, but statistically speaking, we will not call this as rows and columns. We will call these as variables. Okay, so why it is called as variables? Because it will vary person to person. If I say my height is 170 centimeter, that may be different to a different person, right? It won't be constant for everyone. It will change person to person. That's why it's called a variable. Say for example, age here, it will vary from person to person, and that's why it's called a variable. Okay. And then these variables will also have a different name. It's also called as features. Okay, features of data. Okay, and there is a separate theory on feature engineering, feature extraction. There is a lot of theories where you can learn about feature extraction, feature engineering, and all. Okay, so this rows are called as cases because it represents a data of a particular person, right? So this may be someone like John, and he belongs to this team. And what is his jersey number? It's like 30, and his position is some SG, and his age is 27. So this particular row represents a data of a particular person, right? And we call that person as cases. Okay, so this is a variable, and these are the cases. On a whole, along with the cases and the variable, this is a record of a person. Okay, is that clear? So you need to know what is a variable, what are the cases, and what is a record. Okay, so this entire thing along with the cases and the variable, we call it as a record. Okay, so this data frame can be used in many libraries.